All right, welcome everyone. Today's webinar topic is lean product development, what production managers need to know and why it matters. Our guest speaker is Prithvi Kumar, an engineer who started his career at Steelcase and is currently the founder and principal at 2Gemba, a consulting firm that specializes in product development, including what I found especially interesting for our audience, the role of lean product development in reducing quality issues in production. So he'll tell us more about this topic and really why this is important for production. He also provides ISO 9001 registration and certification audits assistance. Prior positions included product development manager, director of quality assurance and continuous improvement, senior product engineer, mechanical engineer, and manufacturing engineer. Some of his achievements, he has many, include improved product success rate from 35 to 65%, increased production efficiencies from 75 to 98%. He holds a MS in engineering, mechanical and aerospace engineering from the Illinois Institute of Technology. Just a brief reminder of who we are before I pass it on to you. As many of you know, we are a world leader in lean enterprise. We have a catalog of 2,500 products used by more than 14,000 companies of all sizes, including some that you will recognize down here. I know that some of you who are listening today are working in these. Thank you so much for joining. The products include educational games, ergonomic office furniture, as well as ergonomic workshop furniture, including sit-stand desks and so on, which you see here, computer protection, as well as in the logistics space, floor racks, trolleys, electrical trolleys, Kanban systems, signage, safety signage, floor marking, and for Industry 4.0, we have a growing interest for our wireless and on lights and our digital KPI management software and digital screens, as well as more traditional but still essential magnetic whiteboards and accessories. So without further ado, I'm going to pass it on to you, Prithvi.
Thank you, everybody, for having me on. My name is Prithvi Kumar, and I am the founder and principal at 2Gemba Consulting. I specialize in lean product development. It's a topic I'm very, very passionate about. I've spent close to 15 years of my career in both sides, product development and production, and I know how important it is for both sides to be in constant communication with one another. And one of the reasons I really fell in love with lean product development is it's an incredibly fascinating topic, and it's actually a lot more difficult to apply than lean manufacturing because it can deal with some very unquantifiable, intangible aspects, and that's what I'll be talking about today. Yeah.
Thank you.
So my goal for today is for everyone that's listening to take away at least one thing about product development that you can begin talking about or having a conversation about right at work, tomorrow, ASAP. So without further ado, I'll jump in. I know we only have about 35 to 40 minutes before we get into questions, so I'll try to keep this fun and I'll try to keep this moving. So all of us assume in product development and manufacturing that the cost of the product really comes in at the manufacturing stage, because that's really when a lot of companies will start investing money in tooling and setting up assembly lines and things like that. And the engineering aspect, typically people don't assume it's costing as much because it's just engineering time or testing time or things like that. But 80% of the cost of a product actually gets baked in during the design phase. So although the design phase is only accounting for about 5% of the traditional cost accounting structure, its influence on the product cost is closer to about 80%. Every design decision that gets made is locking in some design detail or manufacturing detail further downstream in the process. So when you look at the cost of product development and when the failures actually get identified, usually in traditional companies, the failures or like the design issues or the quality issues usually get discovered only towards the latter end of the phase during like launch or production. But that is also when it is the most expensive to fix a quality issue, because you've got your backup against the wall for a deadline. You don't really have much room to navigate or make a good decision for the product. So typically a lot of compromise decisions end up getting made at that time, which allows the manufacturer to save some cost, but it's not necessarily the right decision for the product or the customer. So on my next slide, I kind of talk about how product development makes people feel. You know, as like both a product development manager and an engineer on, you know, on the ground, these were things that I constantly felt like it always felt like we were flying by the seat of our pants. You know, we'd get all the way up to manufacturing and realize that there was a small design detail that can't be tooled. So then you have to come back to square one. You know, the deadlines are always yesterday, right? Can't get it done quick enough. Boss needs it yesterday. Another thing you end up hearing quite often is, I've got too many things on my plate. I can't get to that task quite yet, or things keep getting added on at the last minute. So product development, really, it's a very stressful process, the way it works today, and it can lead to a lot of like burnout on both the manufacturing side and the product development side, letting people just kind of leave the company or, you know, try to find some place where it's less chaotic. But moving on, what we've really got to realize is that product development, it's a very inherently variable process. Like, it is truly a chaotic process. It's truly an unpredictable process, because at the end of the day, it boils down to being a learning process, right? You don't know what you don't know today, but by the end of the week or by the end of the month, there's a certain set of things that you have to convert from a unknown to a known. And a lot of times the engineers, they just don't have enough of a clear picture or enough information to be sure of something or what step to take next. So the key really in this is acknowledging that product development is more of a knowledge management process. The way I like to think of it is every product that gets developed should be treated as a knowledge work job shop. And you have to have your systems and tools in place to deal with that job shop environment, where the key to launching your product faster and with less quality issues is by learning quickly. And how can you go about converting your unknowns into knowns as quickly as possible? So the only way really to reduce the unpredictability and the chaos is to acknowledge that PD is more of a knowledge management process, and you really have to work on things that allow you to learn quickly. So that brings me to my next slide, which is how lean product development tries to address all of these issues with the unpredictability and the learning. So lean product development has three legs. So if you look at it as a triangle with three sides, on one side, you've got product and process. On the other side, you've got skilled people. And then on the bottom of the triangle, you have your tools and technology. So on the product and process side, there are three steps. One, the first step is to deeply understand the customer, right? So the ultimate waste in product development is designing or developing a product that your customers don't want. You're solving a problem that doesn't exist. And so if you're working on products where you haven't really spent enough time understanding the customer's needs, you're going to end up with a product that doesn't resonate with the market. So that is the first step in lean product development, is really deeply understanding your customer. The Japanese word for this is kinto, and it really means deeply understand customer. The second step is set-based design. Set-based design is a methodology that's a little different from iterative, where in iterative, you only take one concept and then you keep iterating on how to make that one concept better. In set-based, you evaluate multiple concepts, or even if you do settle on just one product, you break that product down into its feasible subcomponents. And then you evaluate multiple options for each of the subcomponents, and you delay decision-making until the last responsible moment. And as you eliminate the weak combinations, you end up with the most robust combination of solutions left. And that makes the product a lot more robust and a lot more likely to be innovative, and also be a better product to meet the customer's needs. And then the last step on the product process side is, of course, creating level flow through cadence and pull. So by this, I mean, you have a lot of wastes in the product development process. So just like in manufacturing, where you're trying to eliminate waste and eliminate waiting and delays and things like that, you're doing the same thing on the product development side, except it's a little bit more different because you can't really take an engineer's task and break it down into a 60-second chunk of work, right? Like how we do in manufacturing for assembly. You can't really break down an engineer's task to that level. So you really have to work on other ways of doing that, and I'll get to that in a future slide. On the next side of the triangle, you have skilled people. So on this side, you're really working on developing your people and your teams to be as technically competent as they possibly can be. Toyota actually uses what they call a chief engineer system. The chief engineer is somebody that owns the product. So for example, Toyota Camry has a chief engineer. Lexus, LS300 has a chief engineer. The Toyota Sienna has a chief engineer. The chief engineer's responsibility is to be the champion of the customer, or like the voice of the customer. And he leads a small team, and he is in charge of basically developing the concept for the product and then getting it all the way through manufacturing. He does not have any formal authority over all the functional departments. So for example, body structures or tooling. The chief engineer doesn't have direct authority over them, so he can't just go to them and say, I need you to make this design happen. He has to win them over by getting them to buy in to his concept vision. So let me give you an example. So when the Toyota Sienna minivan was being developed for the US market by Toyota, up until that point, the only minivans that they were making were the much smaller Japanese versions. And in Japan, the roads are small, city is small, people are not really using it to haul a lot of goods. Whereas in the US, a lot of people use their minivans, they'll take the seats out and they'll use it to transport like 8x4 MDF sheets or plywood sheets for like home improvement projects. And the chief engineer saw that this was a really important need for the concept, like having a large space, but it required the body structures guys to come up with new tooling and new structures to have this much larger minivan manufactured. So he actually brought the body structures head of department to the US. They spent an entire day at the parking lot of a Lowe's just watching customers load their cars and their Jeeps and their SUVs. And by the end of the day, the body structures head realized, yeah, this is definitely a must for the product. It's going to make it more successful. And when he went back, they authorized whatever tooling the chief engineer needed. The next thing is to develop technical competence. So the way you do this is by really building more of a learning organization. Toyota does this by making their employees go through a very rigorous internship process, as well as like an apprenticeship model where they have to spend multiple months and years at the Gemba. They spend some time at the dealerships, they spend some time on the engineering floor, they spend some time in the product development, and only after they've worked their way through all of these fundamental apprenticeship levels are they then allowed to move into the product development team. The next thing is to integrate suppliers into the development process. Now, you know, even if when you think about manufacturing versus development, a lot of companies, manufacturing is the supplier to the development team, right? So why not get their feedback earlier on in the process? This is one of the keys to reducing quality issues in production. You have to get feedback from your downstream processes much earlier in the process. And then the last one is build in learning and continuous improvement. So use things like Hoshin Kanri, A3 management, reflection events, things like that, to allow people to reflect on mistakes made at the end of every project, at the end of every week, so that all of that can be converted into some sort of reusable knowledge. Then on the bottom half of the triangle, you have tools and technology. So one, if you are going to use technology, make sure that your technology is aligned to fit the people and the process, not the other way around. The second one is aligning your organization through visual communication and management. A lot of lean product development companies have this room. It's called the Obeya room. Obeya in Japanese means like a war room or a project room. And it's basically a place where management and the product development team can have all of their information displayed, all the critical deliverables, everything related to the project. And at one glance, they can know where they are on the project, what still needs to be figured out, what are the roadblocks, how can management help, things like that. So it allows the team to move much faster without having to wait for like these decision review meetings or milestones. And then the last one is powerful tools for standardization and organizational learning. Pardon the spelling error there. This part is really about creating reusable knowledge. So every project, every product launch generates new knowledge. And if you can't convert that to some sort of reusable knowledge database that you can reuse on a future product, that's kind of how you build in that reduction of cycle time in development. So if I can test a product to failure on project A now and store that information in my database so that on the next project I don't have to retest, that's an example of reusable knowledge. So my next slides, I'm going to talk about the 8 wastes of product development, and then we will end. So the benefits of lean product development are reduced long development cycle times, reduce high costs of development. You can create more innovative, robust solutions because you're evaluating your ideas in sets. Improve chances of successful product because you're spending more time upfront trying to understand your customers, so you have a better chance of product market fit. By involving suppliers and manufacturing, all the downstream teams earlier in the feedback process, you can also design in quality, and then you create all this reusable knowledge that, you know, it's not going to waste. So the 8 wastes. So the first waste falls under the category of mura, or variation. And the first waste is process variation. So process variation is essentially everyone on your team is doing a task in a different way, because there is no standardized way of doing that task. So what happens is, for example, if I assign a CAD drawing task to 2 engineers, George and Jack, George does it in 5 days and Jack takes 10 days. Why did Jack take 10 and why did George take 5? There was no drawing template so Jack was just kind of doing it how he had been taught to do it, maybe his old job, George was doing it a newer, maybe quicker, better way. But at the end of the day, as a manager, it becomes hard to rely on your teams and rely on meeting deadlines if everyone is doing things in a slightly different way. So you have to establish standardized way of doing tasks. So earlier I said engineering, it's kind of hard to standardize tasks like that, but you can provide checklists and templates, things that allow them to follow a basic process at the very least. The next waste is task arrival variation. This also falls under the category of Mura. So task requests that arrive at varying times without any schedule or predictability, it can lead to varying delivery of the completed task to its downstream customer. This is very similar to on the lean manufacturing side when you have an unbalanced assembly line where you have one line has more tasks than the next operator. So it's, it's got a lot of fluctuation. And this leading to a bottleneck. So this is kind of similar, but a better analogy to really describe this is if you think about cities that have a freeway on-ramp. In rush hour traffic, when cars are coming off the on-ramp and merging onto the freeway, a lot of times there's like 6-7 cars all coming in together, and as they try to merge into the freeway, they create this wave of turbulence that kind of starts propagating its way all the way back, right? So they start creating jams as each of them is trying to zipper merge into the lane. Whereas if you look at a metered on-ramp where you've seen those stop green and red lights that meter how the traffic is merging onto the on-ramp. So that's basically trying to control task arrival. It's trying to control the rate or the flow at which the traffic is joining the freeway traffic so that it causes less turbulence on the freeway. Then stop and go tasks would be your next waste. So this is every time a person has to stop a task and pick it up again at a later time. There's a mental setup or a reorient time involved. A lot of people believe multitasking is a must-have skill. In product development, it's actually bad. In reality, it's really difficult to manage more than 2 tasks at any given time. So anything more than 2, you're really not doing any of the tasks justice. And because every time you switch between one task to another, you end up having this mental reorientation of setup time that delays it. One of the things I've seen in my job is we had more success when all 3 engineers were working on one project as opposed to each engineer working on a different project. And we would try to make sure that every engineer was only working on any one project at any given time, and that helped a lot with eliminating this waste. The next waste is called system over-utilization. That's a really long word. It falls under MURI or overburden. And essentially what it means is when you overload a system or a resource past 60% utilization, all the work in the system is going to take much longer to get done. And this follows a law called Little's Law, which basically says the minute a system is loaded past 60% of its available resource, the queues get doubled. All the work in the queues will now effectively just get doubled. And I think one example for this is if you take an engineering team, like say 3 engineers, they each work a 40-hour work week. If you load them up for 40 times 3, 120 hours, and expect work to get done, it's never going to happen. In reality, those engineers are spending a lot of those 40 hours on meetings, checking emails, responding to firefights, things like that. I would actually say a closer, more true representation of what their actual available capacity is. It's closer to about 24 hours per week out of that 40. So really you want to load them for 24 hours, not 40. And your tasks are much more likely to flow smoother. The next waste is unsynchronized concurrent tasking. So concurrent engineering or concurrent tasking is a big buzzword. Right now, everyone's trying to do it, but it doesn't work if it's not executed correctly, right? So one of the ways waste creeps into the system is when concurrent tasking is done, but it's not synchronized properly. What basically happens here is the key to getting this right is to share information with your downstream customers concurrently, but let them know very clearly how much of that information is stable and how much of that information is likely to change. So we know the product development, things change rapidly. So the key here is to really get a good grip on how much of the information that you're passing downstream earlier is stable information that they can continue working with. So for example, you want your tooling guys to start tooling earlier, but you don't want to give them the full design, like, because the design's not firm yet, but can we give them an approximate cubic foot of the steel or the material they're going to need for the tooling, so they can at least purchase the raw material in time to save a couple of weeks? That is an example of synchronized concurrent tasking. The next waste falls under what I call as a category of muda, or knowledge waste. We talked about how lean product development is a knowledge management process. So there are a lot of wastes that render this knowledge ineffective. So that's what knowledge wastes are. So the first one is wishful thinking. This is making decisions blindly without having data or hard evidence. You have a lot of managers that just kind of hope that things go according to plan, and then they kind of wait for a miracle to miraculously put things back in order. It's really not going to happen. Handoffs, that's the next knowledge waste. So this occurs when you're transferring information or material from one team to another. This is quite similar to the lean manufacturing concept of a large batch transfer. If you take a professor who is teaching a course in a college, on his best day, he is still only effectively transferring about 30% of what he wanted to coach students on. And this we see a lot of times. So when design is done and they're transferring all the information, the drawings, over to the purchasing department or the manufacturing department, if those teams were not brought in much earlier on and given like stable information in bits, now they're having to deal with a big dump of information on their laps that they have to go through now without any context of how design decisions were made earlier in the process and things like that. So it leads to a lot of misunderstanding, miscommunication, and potential quality issues in production. The last waste is scatter. Scatter is any action that disrupts the flow of gaining knowledge, making it useless or ineffective. So some examples of scatter would be things like reorganizing the team in the middle of a project. So what this does is it forces your teams now, they have to relearn how to work together with each other. Increasing the team size in the middle of a project. This also rarely works because you're now increasing the number of interactions between your team, leading to more handoff, more miscommunication, more misunderstandings, more waste. Harassing team for faster results. This only works for the person that's doing the harassing, nobody else. And adding work at random intervals, changing the scope of the project at the last minute, and putting a focus on firefighting instead of root cause analysis. These are all examples of scatter. So that brings me to the end of my 8 wastes and this quick introduction to lean product development. I know I threw a lot of information out at you guys today, and I was talking pretty quickly. So if you have any questions, please feel free to contact me either on my cell, you can send me a text, or you can reach out to me on LinkedIn, or send me an email at pk@2gemba.com. I also write a blog at www.2gemba.com where I talk about a lot of these, I write regularly about a lot of these lean product development concepts. So please feel free to read my blog and subscribe if you find the information useful. So with that said, I'll hand it back to Jabril, who's been a wonderfully patient host.
Thank you very much, Prithvi. Excellent. And even better, I saw the slides ahead of time, but even better with the explanations. Learned a lot. Very curious about the chief engineer role, and tell us more about that role and your experience with that compared to other existing roles, I guess, compared to project managers, product managers.
I would say that in today, like in the US, I would say the most similar role to Toyota's chief engineer is really the product manager, who has to basically figure out what the product roadmap is, what the product strategy should be, understanding the customers. Like in today's world, especially with a lot of these web-based and tech companies, the product manager is really that chief engineer. And so like my last job, we tried messing with that concept of a chief engineer, but unless you have someone that's got 20, 25 years of experience that the team can just like immediately trust, that they know that this person is the best of what they do and we should listen to him because he knows what's best for the customer. If you don't really have a person like that, it's hard to put that chief engineer system in place. Like at Toyota, the chief engineers, they spend almost 15 to 20 years at Toyota in product development functions before they're allowed to become a chief engineer.
All right, yeah, very, very interesting. I wonder how many companies actually have that. So you mentioned that some world-class companies.
So Toyota does it, Honda does it. From what I've heard, I believe some of the naval shipbuilding companies are experimenting with the chief engineer system. But if you can't really find someone like that, I think the best alternate is for potentially a product development manager, maybe someone on the sales side, maybe someone on the design side to kind of come together and try to work together in the role of one person. But they have to be really well aligned on what the product strategy is.
Also a question that came to mind is the role of continuous improvement teams and managers. It seems like, for example, what we just discussed, plus a lot of what you described, could be on the to-do list of the continuous improvement team, right? That bringing on board, like improving the processes by bringing on board someone who'd be in charge of this integration of all the processes, or the OVER team, the meetings and so on.
Right, and so what I did at BDI was rather than have like a continuous improvement team that had been doing a lot of continuous improvement on the manufacturing side, then come in and say, hey, we're going to now teach you guys how to do continuous improvement, or like basically problem solving, right? Use an A3 form and go through plan, do, check, act. I actually found it a lot more useful to take on the role of like lean coach for my own team and train them in problem solving. So even before we started lean product development training, we trained on problem solving, plan, do, check, act, giving them the basic skill set of root cause analysis, how to do it, how to define a problem. And we spent close to 2 years just using basic problem solving tools to stabilize a product development process before we could even start working on improvements. Because every time I tried to work on an improvement project without stabilizing, it was like walking on quicksand, like the improvement wouldn't stick. And my teams were like frustrated. They're like, this is not working. I'm like, that's because our very foundation is shaky. So we had to really work first on getting out of a firefighting mode. And I had to really push my managers and my CEO, and they had certain what I would call destructive behaviors to lean, where they were always like coming in at the last minute and say, can you add this feature on? Can you do this? Can you do that? So we really had to like focus on like trying to reduce some of these what I call destructive behaviors. and stabilizing the foundation, making sure everyone understood what lean was about before we could start saying, okay, before I start looking at trying to create a level flow for my tasking, before I can put a Kanban board in place, here's everything I need to fix. So I would say the first focus really needs to be on stabilizing the foundation. Use just basic root cause problem solving, do a mind map, do a brainstorm with your product development teams, maybe include some people from manufacturing as well, and look at past projects, see what failed, what worked, do some reflection events, and then kind of create what your improvement roadmap's going to be.
All right, thank you very much again, Prithvi, for this presentation on the principles of lean product development and also why it's important for production managers. I hope you all enjoyed it. This is part of what we call the CESA Systems Academy, which started as a showroom in which we hold hundreds of participants, or invite hundreds of participants per year to join as a kind of a think tank, discussing how simple tools like those you're familiar with that we provide can make a substantial difference when used properly. And we also have a number of catalogs available. If you'd like to request, you can either download them directly from our website, or feel free to reach out by email and I'll send you a copy. We have catalogs for Lean Office, for training games, what we call Lean Dynamics, Industry 4.0, so digital KPI management, ergonomics. So hope you will connect with us. And also would like to invite you to join our LinkedIn group that now actually has grown pretty well these past few weeks. We are up to 1,600 members now. No spam, only useful content. So you can find us on LinkedIn by going to groups or just typing linkedin.com/groups/8605844. And I look forward to seeing you there.